Alright, this is going to be a quick video on momentum and impulse. A couple definitions here. Momentum is a combination of object's mass and its velocity. So momentum is equal to mass times velocity. They didn't make up a special unit for this one, so momentum is just measured in kilogram meters per second. When we think of momentum, we can think of it as how hard it's going to be to stop the object. If the object is big or the object is moving fast, it's going to take a lot to stop it. Or we can think of momentum as how much an object could do if it was in a collision. So for example, the heavier an object or the faster it's going, the more effect it will have in a collision. Secondly, impulse. Impulse is equal to force times time. Again, there's no special unit here. We take newtons times seconds, and that'll be our unit for impulse. Impulse is just another way we're going to see here. Impulse is the change in momentum, and we're going to see that this is just another way of looking at Newton's second law. There's no trick here. It's just another form that Newton's second law could be written in. So using Newton's second law, let's show that impulse is the change in momentum. Newton's second law says F equals ma. Here, if I expand A to be v2 minus v1 over t, or acceleration is equal to the change in velocity divided by time, and substitute that into Newton's second law, then I'm going to bring the t over to the left-hand side by multiplying both sides by t. And now I'm going to distribute the mass to both things. And here I can see that this is the final momentum, and this is the initial momentum. And here I can see that force times time is the impulse. And so I can see that impulse is equal to the change in momentum. That's not, there's nothing here. This is just a restatement of Newton's second law. It's just restated in a different format. This is Newton's second law stated in terms of impulse and momentum instead of force and acceleration, but there's nothing new here. So those are just two new definitions. Let's use them in a couple problems, and that'll be that. So a baseball bat, or a baseball, 145 grams, is coming towards a hitter with a velocity of 35 meters per second. The ball is hit, it makes contact with the bat for 187 milliseconds. The ball leaves the bat in the opposite direction with a speed of 70 meters per second. What is the average force applied to the baseball during the collision? So remember, impulse is equal to the change in momentum. Careful here, because momentum is mass times velocity, momentum is a vector like velocity was a vector. So impulse is equal to force times time, and momentum is equal to mass times velocity. So mv2 minus mv1 is my change in momentum. I have a time of 187 milliseconds. Converting that into seconds, 0.187 seconds. Mass, 0.145, times my final velocity, which was 70. But I got to be careful here. If the ball came in this way and then came back out that way, one of these directions, this one or this one, has to be a negative. So let's make the way the batter is standing and hitting the ball the positive direction. That means that when it leaves the bat, it'll be leaving with a positive 70 meters per second. When it came in, on the other hand, that's here's the pitcher throwing the ball. When it came in, it must have been going then with a negative 35 meters per second. So it came in one way, I called that way negative. It got hit back out that way, I called that way positive, so this one's a positive, and this one's a negative. Alright, big equation here, but nothing tricky. 0.145 times 70 plus this negative and this negative become a plus. 0.145 times 35. So I get a total change of momentum of 15.225 kilogram meters per second, equal to my impulse. So I'll divide that 0.187 out of both sides. And I get a force of 81.4 newtons, and as you might imagine, it's in my positive direction, as it's what's caused the ball to go in that positive direction. Could have done this exact same problem by calculating the acceleration, dividing by time, right? Velocity 2 minus velocity 1 divided by time, and then using F equals ma, but this is just another way of doing it. One more example here. A ball, 0.8 kilograms, is traveling towards a wall with a speed of 3.5 meters per second, hits the wall and rebounds off, experiencing an average force of 10 newtons for 45 seconds. Determine the final speed of the ball. Again, impulse is equal to my change in momentum. My impulse here is force times time. My final velocity is the part I don't know. Here's my initial velocity. I'm going to call whatever the initial velocity was positive. So then the force, let's say here's the wall. When the ball hits the wall, the force that the ball would apply is in the opposite direction, so that's going to be a negative. So I've got negative 10 times my 0.45 is equal to my mass, 0.8 times V2, minus 0.8 times 3.5, so negative 4.5 is equal to 0.8 V2 times 3.5, and the negative 2.5 over here. Bring it over, negative 4.5 plus 2.5 is equal to 0.8 V2, which is 2, so 0.8 V2. So my final velocity of my ball is, that's a negative 2.5 meters per second. Remember, I said it was going in with a positive 3.5, so it bounces back in the opposite direction at negative 2.5 meters per second. Again, you could have done this problem by using the mass and the force to determine the acceleration, and then using the acceleration formula to find the final velocity. Either way, it doesn't make any difference, but in terms of impulse, force times time, and change momentum, we can solve the problem as well. So the most important thing from this video, momentum is mass times velocity. We can think of it as how much that object could do in a collision. Impulse is the change in momentum, and that quantity is given by force times time. And we can show that impulse is the change in momentum by using Newton's second law. And then we can do some Newton's second law problems, but in terms of the equations for impulse, because one was derived from the other, of course they are equivalent.